All right, guys, anybody just check in? Anybody have any questions? If you notice, the quizzes have been graded. So you might want to take a look there. You can make corrections. If you have a question from there, you can ask away. If you have a question from homework, let me know. All right, I'm kind of amazed. I didn't know if I'd be able to finish grading all these quizzes, but I did. I kind of hate having class and I haven't graded a quiz from the last thing. I kind of hate doing that. So I drop everything else and just grade them like crazy. Let's see, I got a request from section 5.3, number 27. All right, let me share this real quick. Kapow. So this is the one you're talking about? I believe, let me see. Where's my, okay, here's chat. Bam. Yes, okay. So this one says, oh yeah, okay, so we haven't, so this is important. Okay, good, I'm glad this is coming up. Because I knew it was in here somewhere and I was gonna talk about it tonight. I just couldn't remember which section this was in. So intermediate value theorem. Some of you guys have done section 5.3, so let me just do this. Let me just show you what this says. This is perfect. I love this question because this is exactly in the plans for tonight. It's almost like I planted somebody there. Okay. For such a highfalutin name, the intermediate value theorem, I mean, that sounds like it's going to be painful.
You're still sharing, so if you start drawing, it'll be hard.
Okay, thank you. I desperately need anybody to help me whenever I'm doing that crazy stuff. So the intermediate value theorem. So if I have a polynomial function, and there could be other functions, but right now we're focused on polynomial, and what is it about polynomial functions? What is it about their domain? What's their domain always, unless it's been changed? Unless it's specifically stated otherwise.
All real numbers.
Yeah, let me spotlight me, just because I'm a attention whore. There we go. Hey! So if I have a polynomial, just, hey, how's everybody doing? We're doing this little Loch Ness Monster thing, right? And it wants to go here. What is the only way it can get there? It must cross through. It's got to go through the x-axis at some point, right? So if, let's say this is 7 and this is 8. And here's my function. Here's my polynomial function. So f of 7 is greater than 0 and f of 8 is less than 0. So what does that mean is true between 7 and 8? Well, that's pretty obvious now since I drew it.
It crosses the x-axis.
So it has a 0 there, which is kind of like the dominating idea in this chapter. It's got a 0 between 7 and 8. That's it. I mean, it sounds like it's going to be some insane thing. Okay. So I look back at this problem. Let me pull it back up. Oh, shit. Hold on. I closed the book. I got to open it back up. All right. So let me show you. Here we go. Sorry. Which problem was it again? 27. Okay. And let me tell you, let me stop sharing for a second. I feel like I can't do this without telling the whole story here. I mean, this is the immediate thing that we're interested in as a consequence of this. But if I didn't want to, if I say I have a continuous function, continuous, What do you think that means? Like, what would a function be that isn't continuous?
A piecewise function.
Yeah, piecewise could be. I love it. One way to have a function that's not continuous is for it to have like a jump, like it jumps. Or it could have somewhere where it goes to infinity, like an asymptote, right? That's discontinuous. Those are ways you can get around this. If you can suddenly just jump there, like teleport there, then, you know, screw this whole thing. It just goes out the door. But if I have a continuous function, then f of 7 and f of 8, the function has to take on every value between those. It's got to get from here straight to there. So it can't skip over any values. It's not allowed to do those kind of things over there, which means it must equal 0 somewhere in between those. That's the most immediate part of the intermediate value theorem that we're interested in. Okay, so I decided I wasn't going to bring this up because we hadn't really brought up this word yet, but I figured what this shit. I'll tell you what this word is. That's the whole story behind the IVT. And if I look back at this problem, now you can see what you've got to do. Confirm that the polynomial has at least one 0, because of course, this could go through multiple times, has at least one 0. So now what do you have to do that? I got some chats happening. Let's see.
Check both x values.
Yeah, if you plug in 1 and you plug in 3, what are you going to look for to happen?
A negative y and a positive y.
Yeah, they've got to change signs. I love it. So if f of 1 is negative and f of 3 is positive, or the vice versa, then that definitely guarantees it's got to attain a value of 0 somewhere between those two. How are we doing up there? Okay. Okay. So let's see, yes. The y values have opposite signs, yes. And that's what would tell you that it has at least one 0. I like it. Okay, anything else? That was a beautiful question. Oh my gosh. That went right into my plans. Anything else? No? No? Going once? Going twice? Okay. And I guess everybody did see that I graded the quizzes, so you can start working on those corrections. When are quiz corrections due?
Day of the final.
Good.
Day of the final.
I think it says something different on the syllabus, but that's something that we changed once the class started. I just decided just to do that. But you can turn it in whenever you get it done. But you can only make corrections once. So there's a bit of a thing there. You got to be careful. All right. Okay, so let's get back into where we left off. And that was in section 5.5. So I want to show you something that the book doesn't tell you about. I think I brought it up yesterday. Was this idea of upper and lower bounds. So I want to show you something that's really more useful than Descartes' rule of signs. And let's actually start with that. Let's actually remember what Descartes' rule of signs says. Poor little chair. So I'm going to work with this bad boy here a bit. First thing I want you to do is make a list of possible rational zeros. Does anyone not remember what that means? Okay. And I want to make, well, okay, I'll make this connection in a minute. Oh, this is going to be good. I can't even say the word connection. My whole job is about communication. Shit. All right. So, I mean, it's going to be plus or minus. What do you guys got?
1, 2, 4, 6, 12, 24.
Eight.
Oh yeah, there you go. 3 and 8.
Like, sweet. And it's easier. I don't have to put it over anything because this is just a 1. So it'll just be over 1, and so nothing changes. So there could be fractional ones if there was a number out front that wasn't 1. All right, and this is still a long-ass list. This is 1, 2, 3, 4, 5, 6, 7, 8, 16. So there's 16 possible values that I'd have to check. So here's what Descartes would do for me. Let's remember, what does Descartes say? You need a C there, buddy. There you go, buddy. Sorry, Descartes. What does Descartes say about this directly? The fact, oh man, why am I rewriting this? Oh, I don't know, Jeff. Just do it. All right. Somebody keeps logging in and logging out. I love it. Does anyone remember Descartes? You look at what?
The number of time it changes the sign.
Yes. So here's one sign change, no, and then here's another sign change. So there's 2 sign changes. What does that mean?
2 or 0.
2 or 0 what?
Positive sign changes. Positive.
True.
Sorry, just kidding. Positive, possible 0 roots. Positive
Yes.
roots.
Positive, real roots. I want to make a distinction here. You guys see there's 2 words up here that are very important. This list is all the rational zeros that are possible. Isn't it remarkably probable that you might have to eventually do quadratic formula or something when you break it down because you reach something that's not factorable? I'm not going to get rational answers then, but they will be real, possibly, right? Anyway, all right. So I could get an answer like 3 plus or minus the square root of 2. So I get 2 real roots there. They're just not rational roots. Okay. So this list will be rational possibilities. So you could get none of these work because all the answers are like square root of 7 or something. That would suck a lot, but it will. And what else does Descartes say? This is one part. What's the other part? So he says this. How do I do the other part?
Don't you put in negative x and then do that again with the sign changes?
So remember the shortcut was the odd roots change sign and the even ones don't. Right? Because negative cubed is negative. Negative squared is still positive, so that sign doesn't change. So now I see 1 change in sign. So what does that mean?
You have 1 or 0 negative real roots.
Say, sorry?
You have 1 or 0 negative real roots?
Nope, no.
Nope.
You got 1, or you can go down by 2, but then you have to owe somebody a root, which isn't something we can do. So you always have to go down by 2. So when it's 1, it's kind of nice, to be honest, because then you know you're guaranteed there is 1 negative real root. So if this is the only thing I got from this, I would try the negative ones out first because there might be no positive real roots. But this still sucks. So let me put up here real quick. 2 or 0 positive real roots and 1 negative real root. Okay, so I'm going to take this away. Now, we're going to see in a minute, Descartes is pretty lame. Not him as a man, I'm sorry. Descartes' rule of science is a little bit lame. When it works, it's really, really good, but it doesn't do that very, very often. Okay. But still, you got to know it. Too bad for you. You got to know. What I want to do is show you something a little more powerful. Let's try to go ahead and divide this by, let me say this both ways. Divide this by x minus 6, right? Divide this by x minus 6. So what am I going to put in the penalty box?
6.
6. I love it. Go ahead and do it. Do it. Catch up to you. Look at that. Did anybody get really excited for a second? And then went, oh, come on, what the shit, Jeff? All right, so that didn't work, but watch this. This is so kick-ass. Are there any changes in sign in these? So there are, so what I've got is I've broken this down into x minus 6 times barf, right? Times blah, all this shit, right? There's no changes in sign, which means there's no positive roots outside of this possibility, which it didn't even go into evenly. I'm not sure if you guys really get that idea. So another way to look at this, and then I'll really make sure you understand what this means. If I write this down, what is this?
X squared.
Good. If I plug in numbers above 6, isn't this always and forever going to be positive? So isn't this above 6 will always be up here? Is there any chance there's a 0 above 6 then? No. So what we have found is an upper bound. 6 is an upper bound. So what can I throw out of my list?
8.
Everything
8,
above
12,
6.
24.
8, 12, 24, yeah. That's more directly useful because you have to pick something and try it anyway. And if it doesn't work, this could still be, if it turns out they're all positive, that tells you more than just it didn't work. If it doesn't work before I told you this, it doesn't mean shit. You cross out that one number because it didn't work. Now I can cross out 1, 2, 3, 4 numbers. All right, do everything we just did now, do it with negative 6. Is everybody cool with what happened here? Any questions on this? And then I'm going to summarize what we've discovered after we do the negative 6. Okay, not seeing anything. So now divide by x plus 6, put a negative 6 there. Oof. What is it? Is it 384? Negative. Now, is this the same? This seems like it goes against it, but now here's the second part of this 2-part thing. Looking at lower bounds. If the result I get changes sign, and again, see how that matches up with Descartes' second part of his rule? then the same kind of thought process is there's nothing below -6 that will work. So if you divide something by any number and the answer comes out changing sign all the way through, you have discovered a lower bound, which means I can now cross out all of those. It's got to exist between, it's got to be between -6 and 6, not inclusive. So now I've only got 8 things to check out. By doing 2 things, I've cut my list in half. That is much more directly useful. Hopefully, oh, okay. So I can look at it the same way I did before. Either one thing is to realize this changes sign, so there's no negative roots that work for this piece. So beyond -6, there's going to be no negative roots that work. Another way is I have broken this guy up into x plus 6 times this. What was it? Right? So if I put something, now stay with me. If I put something less than -6 in here, that's positive. That's positive. Are you guys with me? If I put something in less than -6, that's positive always. That's negative times negative is positive. That's positive. And this will be negative, negative, positive. Everything is freaking positive for every number below -6. So is there a possible root below -6 if it always stays positive? No, because of the intermediate value theorem thing we talked about, right? It needs to have somewhere where it's negative so it goes through the x-axis. We can see that it never changes sign after -6, below -6. It's the exact same thought process for the upper bound. It's really kind of cool. And this also, hopefully, if you really think about this, this explains Descartes' rule about the negative stuff a little bit better. The alternating signs, when I put a negative value in, allows for this to become all positive, which really screws the chances of a root happening. Okay, is that better? Is that all right? So let me summarize what we just learned. And then we'll actually finish this problem out. So everybody got this here? Down here? Okay. So the upper and lower, so to do an upper bound, if I synthetically divide by something, and my result is all positives. And really, it would be no sign changes, but they're all positive. This means that this is an upper bound. Whatever this number is an upper bound. Which means anything above that I can destroy, including itself if it didn't go in evenly. So it even works if it goes in evenly and all the other numbers are positive, it still is an upper bound. Okay, maybe. And then basically,
And the last part. What was that last part that you said about the upward bound, even if they're positive?
even if this last number, so I get all positive numbers, let's say that the last one is 0, like it went in evenly, right? It still means it's an upper bound.
Okay, that makes sense.
Okay.
And
And
what
then
if all of them come out negative? Would that still be the same? Because you started to hint at it and then you moved away.
Yeah, technically, yes. As long as they have all the same signs. So it's the same idea as Descartes' rule. As long as there's no sign changes. And then for the lower bound, as long as the sign changes from step to step. What most happens is you get all positive or positive, negative, positive, negative. But it's not impossible to get all negative. That's possible. So yeah. Okay. Oh, okay, that's all right, man. You do what you got to do. Okay. where was I? Oh yeah, so if I do this and I get results here that would be alternating signs, then that would be a lower bound. And I can kill anything that's below it. So now you start to see a strategy. Would you ever, on the first try one of your bigger numbers? No, right? Because if I try something in the middle or something, and I get this, I can just cross out so much shit. Now, I'm not saying it's guaranteed to work that way all the time. Oh, well, too bad. Sometimes the answer will be freaking 24, won't it? It just will. But how often? Not very. So for me, I would always start somewhere in the middle, unless, you know, I can do one real quick. I can do that in my head, basically. So I might try there, and I might get lucky. Okay. All right. So let's see. So what I want you to do is finish this out, and then we'll try another one with this bound theorem. So now you have much less to try, right? You only have plus or minus 1, 2, 3, 4 that you have to try. I'm going to take this away. It's not much here anyway. Okay. Let me know if you find a number that works, which of course relates to an expression. All right, yeah. Ooh, maybe, I don't know, I can't remember. I can't. I did this example a long time ago, and I can't remember how it factors now. Anybody else get one that works? I got a couple people private message me 2 things. Let me see if that one works. Yeah, it looks like that one works. Yeah. Yeah, everybody that's private messaged me, you're right. So I got a couple people telling me that 3 works. Let's see if we can pay attention. Let's see if we get anything interesting in the results. So 1, 3, -2, -6, -8, -24. Yay! Does this mean anything to me? These results here, in terms of the bounds?
No, because they don't fit anything that we discussed.
They don't alternate all the time. They're not all the same sign, so that means shit. But now what I want you guys to get used to is the minute you're down to quadratic, just freaking factor the thing. Right? Is that factor? And now here comes the other, yeah, Jason and somebody, I'm sorry, I called you off, but well, I think I can say Jason and Hunter, you're right. Right, because how does it suffer a factor? It's x minus 4, x plus 2. So 4 would have worked, -2 would have worked. And remember what Descartes said? 2 or 0 positive roots. So look, I got, if this was equal to 0, I would get 3 and 4, and then 1 negative root. And sure enough, we got -2. That's kind of nice. You know, Descartes like, well, thank you for trying to make me mean something. Sorry. He did a lot of shit. He developed our freaking XY plane, so I think anything else would have just been icing, you know, so. Okay. So let's see. Let me make a problem real quick. Or maybe I should look one up. No, let me make it real quick because I know you like sitting there waiting for me to do something. I know you do. Let's see. Let's see. Gonna take a sentimental journey. Sentimental journey of. Let me see. This would be really nice if you got this right, Jeff. All right, let me write this down because I'm going to pretend like I definitely got it right. I'm going to erase all this business here. All right, so I want you to analyze this first using Descartes' rule of signs. And while you do that, I'm going to double check that I multiplied this thing right. Yay! All right. Boring. Let me see. That's also boring. Let me see. Oh yeah. Interesting. Really? Yeah. All right, what does Descartes say? Let me catch up to you guys. Not much, he's dead. Be quiet. What does Descartes' rule of signs say when applied to this? Anybody have that? Positive real roots, how many possible?
2 or 0.
2 or 0. And then negative real?
1.
Yeah, so this is basically the same sign setup as the last problem. So, same idea. So what are your possible real roots? Sorry, rationals. Use a different color. That was kind of fading. It's going to be kind of a long list, right?
Yeah, plus or minus 1, 2, 3, 4, 6, 8, 12, 16, 24, 48.
Yeah. Sorry. Yes. Gross. But now I want you to realize what I've tried to do for you is the book doesn't give you this. I wanted to give you this because it's really useful. Who's got a good suggestion on what to try first?
8.
Not bad, because it's right in the middle of everything. So if I use 8, and then we can do this real quick. 1, multiply, add. Oh, what is that? Multiply, I think it's that, right? Add. That was very promising. In fact, to get honest, if I start getting crazy big ass numbers, I just say plus plus for a really freaking big positive, because that's all that matters at that point. I can see it ain't gonna work. So what becomes important is, are all the signs positive in this case? And they are. So what does that mean I can do?
Clear out everything from 8 and up.
Yeah, so now I only have to consider -8, -12, -16, -24, -48. All right, I like it. Did anybody try something else first? Or did anybody else try something?
I also tried -8.
Okay, what happened?
It ended up alternating the signs,
Kick ass.
so it was the lower bound.
All right, you can do it, Jeff. I don't know if I can do that. Is that 104?
Yeah, it's 104.
Oh, shit. And then, wait, this is...
-700. Wait, dang it.
I can do it. I can do it.
Okay. All right, you got this.
It's been a long day. All right, and then this is going to be really, really big negative, so this is going to be negative. See how useful that is? Because at this point, you know it's not going to be 0. So who gives a shit what it is, except for the fact that it's negative?
Mhm.
No problem with doing that. That's a smart thing to do. The actual value doesn't matter because it's not 0. Who gives a shit? So yeah, like you said, it alternates, which means I can throw all of these out because -8 didn't work, and everything below -8 is not going to work because of the lower bound theorem. Did anyone find one that works?
That's a good question.
Yes.
So for the alternating thing, that only works if the first number is positive, right?
Well, again, it's sort of like what Jason was talking about earlier. If the first one happens to be negative, which when I say that doesn't happen, if this was negative, I would probably factor a negative out first. But if this was a negative one, then this would be a -1 down here, right? Because it would just drop down.
Yeah.
So negative, positive is a possibility.
Okay, got it. So that would that count as a lower bound then in that situation?
That would count as a lower bound. I like
Okay.
it. And I really want to make sure you guys don't make this mistake. This is sort of like the math equivalent of thinking that cats are the girls and dogs are the boys. I don't have to put a negative number in for it to be a lower bound. 2 can be a lower bound. -80 can be an upper bound. Do you understand? All that matters is, are the results not changing sign throughout? That's an upper bound. Are the results alternating signs constantly? That's a lower bound. They don't have to be positive, negative. Who gives a shit? Maybe? Maybe. Okay. So go ahead and see if you can find a number that works for this. That's all right, Jeff. Well, what happens if we do this? I'm trying to make a good problem for us next year. Yeah, I like that. That's good. Yeah, I like it. That's perfect. Oh, man. All right. I'm going to take this away. So we've already got the information from these. Did somebody find one that works?
Yeah, I think 4 works.
-3
Wait,
also works.
You think what works?
I think 4 works.
4 works? Let's see. 1, negative 5, negative 8, 48. 1, 4, negative 1, negative 4, negative 12, negative 48.
So if you
Yes, go ahead, sir.
if you went through all of the, say, the positives, and you know there's 2 or 0, and you only have 2 left, and you come across, say, 4, and then you can pretty much say that your other positive number that you have left over has to be the 0.
Nope, because 4 might be the 0 twice.
Ah, okay, thank you.
So you got to be a little careful about. I appreciate that. That's not a bad idea to figure out, is there a way to truncate the work at some point and know that I'm done? And that's not a good way. You're right. Good. Okay. And then I can just factor what's left, right? This is not going to be too bad. Oh, get out of there. So everybody else that was saying negative 3, it looks like that works also, right? Because we get x minus 4, x plus 3, and then another, see, they're right there, and another x minus 4, right? So 4 was a repeated root. I like it. So yes, Hunter, you got it. Perfect. So this is, I don't know if anybody else, it's okay if you don't want to admit this. I don't know if anybody out there kind of enjoys this a little bit. Or it could just be me. I'm very used to it being me, but this just feels like, especially with the bounds thing, because otherwise it feels like you have no control and it's just brute force. Just try every damn thing until something works. Holy shit. But when you bring the bounds thing in, you feel a little more in control. And even if it doesn't work, it could still tell you something. That's what's really, really beautiful about this. Not just one thing, but we can cross out many things sometimes if it doesn't work. All right, somebody, I like that. Somebody says it's kind of fun. I'm okay if you're just humoring me because I need that sometimes, so it's okay. All right. What was the next thing? Oh, yeah. So let me show you one more thing, one more of these. So before today, did you have any way to factor this? I really want you guys to stop for a second and realize what I said earlier. Hopefully it makes complete sense now. Synthetic division is a factoring tool. Because before synthetic division, I had no way to do this. Grouping ain't gonna do shit for this, right? What is really nice about this problem that I made for you? Anybody notice?
They're all positive signs.
Yes, which means what about the positive, the possible positive real roots?
There's none.
0. So my list, I can just make it all negatives, right? So what about the negative real roots? Well, I have to look. So what would change sign? If I put a negative x in?
X cubed would be
This one and this one. So it would change, change, change. Right? Is that all right? So it would be negative x cubed plus 4x squared minus 7x plus 6. So it would change, change, change. So there's how many negative real roots?
3 or 1.
I like it. And now what are my possible rational zeros?
-1, -2, -3, and -6.
Get out of 4. All right, thank you. Not too bad. All right, try them out. In fact, what I want to do, here, I want to force you to try one. If we do -1, I don't know if anybody's trying out -1, but if you try it, let's see what we get. You can do it, Jeff. There you go, buddy. What does that tell me right there? What does that tell me? Something kind of dumb, I know, but I just want to make a point out of this.
You've reached the upper bound.
Which is kind of dumb in this case, right? Why is it kind of dumb in this case?
Because -1 is your biggest number.
It was already the freaking biggest possible thing. But still, I just want to show you an example where a negative could be an upper bound. Just to really get it out of your head that positive and negative means anything about upper or lower. It doesn't mean shit. All that matters is what happens. Doesn't matter what this is. Somebody should have gotten one that works by now, I think. There we go.
Yeah, -2 works.
-2 works. You can do it, Jeff. Oh, man. Everybody got to keep your eyes on me today, man. There we go. Okay. And again, look. Anyway, that's enough of that shit. Oh, I'm sorry. Can you go over how it's 3? So this is Descartes' rule of signs. If I look at the original thing, there's no changes in sign. That's where there were 0 possible real roots. Positive real roots. You can do it, Jeff. When I put a -x in, I get negative, positive, negative, positive. 1, 2, 3 sign changes. And I'm about to really hammer home why this changes by 2, if that's still a question. Is that better out there? That's all it is. That's the idea. Okay. But I'm almost certain there's somebody out there that's still like, why the shit do we go 3 and then 1? Why do we go blah, 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 blah. Okay, I'm going to talk about it right now. Right now we're going to talk about what am I left with here? I've got x plus 2, right, from this. And this is
x squared plus 2x plus 3.
thank God. Wasn't sure how much further I could go. Is this factorable?
No.
So what kind of roots will it have? It's kind of a trick question. We don't know. It just won't be rational roots. It could be real, it could be square root, or it could be complex. So if the answers to this were like 1 plus or minus square root of 7, that's 2 additional real roots, right? Well, you have to be negatives, but you get the idea. That's 2 additional roots. But if they're complex, do you understand that complex solutions to quadratics come in pairs? Because where do they come from? When do we get complex solutions to a quadratic?
From the square roots of negative numbers.
And yes, and that's going to be in your quadratic formula, and there's a freaking plus or minus on it. So complex possibilities always come in pairs, which is why this goes down by 2. Either 3 are real negative, or only 1 is real negative, because you have 2 complex. And that's what's going to happen here, I think. Did I make it that way? I didn't even pay attention. It could be, well, let's see what we get.
Yes, they're complex. I tried it.
Because you get, let's see, -2 plus or minus square root of 4 minus 12. Yes, I like it. All over 2. So I'm kind of hoping you guys are pretty decent with simplifying radicals. 4 times 2, square root of 4 is 2. I can kill all the 2s, so I get -1 plus or minus rad 2. So that's why I go down by 2s, because I could get a complex conjugate pair of answers. I like it.
Do you want us to go to that extent when we're solving it?
If it says find all of the roots, yes. If it says fully factor it, you can stop here.
How did you get to that? I don't understand how you got to that from x squared plus 2x plus 3.
Well, quadratic formula, -b, right, plus give or take square root of b squared. is 4, minus 4 times 3 times 1 is 12. 4 minus 12 is negative 8. I mean, right? Just doing the quadratic.
Okay.
And then to get from here to here, I simplified rad 8 to be 2 rad 2. All the 2's cancel. And then rad negative 1 is I. So everything I just said has to be something you can do. Maybe not as quick. I don't give a shit about quick. I give a shit about, do you know how to do it? All right. Okay. I like it. What time we got? Oh, good. We get all right. So everybody got all that up there? Because I'm going to block it right now. Sit my big old butt down. I got to sit down. All right. Well, let me see. I want to make sure I didn't forget anything in section 5. No. All right. So the last thing we're going to do tonight, I want to talk about asymptotes. I should have worn I never synchronized my shirt. Oh, it's dirty. That's why. I've got to do laundry. My Gandalf shirt. Remember my Gandalf shirt with the asymptote? You shall not pass. So I want to analyze where asymptotes come from. And there's 3 types of asymptotes. And can somebody help me out? What does asymptote mean? And it's kind of a weird question, I guess, but there we go. There's everybody, or 3 people. Okay. Oh yeah, thank you. Yeah, I got tired of wearing nothing but math shirts. I figured I'd wear some other kind of geeky shirt. This is my, have I worn this shirt yet? You guys know what this shirt's called? This is what I call it anyway. I call it Death Star Unite, right? Come on, come on. I mean, what else could you call it? I mean, anyway, sorry. All right, asymptote. Does anyone have any feel for what asymptote means?
Like a line that a function never, I guess, crosses, intercepts with?
Yeah, but that could be 2 parallel lines, and that's not really asymptotic. So what you're missing is, and it sounded like you were almost going there, the function has to not just not cross it, but it has to get
like infinitely close to it.
Yes, I love it. You even said the perfect way. It has to get infinitely close to it. So you can pick, so if it's truly asymptotic, you can pick any small number and I can figure out where it gets closer to the line than the small number you gave me. So if you say a half and I go, all right, here, it's closer than a half. All right, then, what about 1 times 10 to the negative 99? Well, if you go away the shit out here, it's closer than that. So it's sort of like, all right, let me blow your minds a little bit. Have any of you ever heard of something called Zeno's Paradox? It's not a, it's, sorry, I don't know why that thought came to mind. It sort of sounded like a strand of cannabis, but it's not that I know of. It could be. If you grow cannabis, you can take that name, Xenos Paradox. Has anybody ever heard of Zeno's Paradox? Okay, here's what it is. And I'll tell you my smart ass reaction when my teacher told me this. So let's say you have town A and town B. Let me draw this out. Ouch.
Is this where you cut the distance in half each time?
You got it. So I got town A and town B, and our hero, Zeno, is going to go to town B. But to get to town B, he's got to go halfway. And then he's got to go half of that distance, and then he's got to go half of that distance, and then he's got to go half of that distance, and then he's got to go half of that distance, and then he's got to go half of that distance. So the fact that he ever makes it to B is supposed to be a paradox. And so what did I say when the teacher told me this? I said, well, tell Zeno that town B is twice as far away as it really is. So that he freaking gets there. Because the real paradox, so that was my teacher's fault. The real paradox should be that he can't even start moving, because in order to even think about getting here, you first have to get here, and 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 you first have to get, so you can't even start moving them. Okay, so that kind of relates to an asymptote, because I can get, so if I have an asymptote like this, and I have a function coming in, it can get as close to this as I want. So I can basically keep cutting in half the distance that the thing is away from this line, and it will never get there if you give it infinity to do it, because I can cut something in half for an infinite time and it won't become zero. Right, at least theoretically. Okay, this is not like folding a piece of paper so many times, or folding a Jerry in a what do you call it? Not at Denny's. Where was it? There. All right. Was it Denny's? It wasn't Denny's. Okay, so I don't know why I just sat down, because I'm going to get back up in a second. But so that's the basic idea behind what an asymptote is. And to be really, really geeky, I always think of it as the space shield, the shield around the Death Star, and pull up, oh shit, you know, so they go, oh, and they just, you know, anyway. And of course, one of them touched it and they blew up because they weren't allowed to, right? Okay, so really horrible. I don't give a shit. So now my shirt is appropriate. I like it. Okay. So the most basic place where an asymptote, in fact, let's make it really specific. Let's talk first about vertical asymptotes. So these will be, of course, things like that. And that's like the one I have in my mind. It's a trap. Wah! So where the shit does that come from? So if this is 2 here, let me say it's looks like this. That would come, does anybody know, before I just say, does anyone know where that would come from? What would the function look like for that to happen?
It'd be like 1 over x minus 2.
Yeah, so it's, and to be really honest, you don't have to know this right now, but considering the way I did that, it would actually be like negative 1 x minus 2. That's
Okay.
no, yeah, not a big thing. But you're right. The big thing I wanted to see there was it's over x minus 2. So vertical asymptotes are walls that you cannot cross through. I want to make a big deal out of that, because horizontal asymptotes, you actually can cross through them, which might be a different idea than some of us are used to. Okay. So if I had this function, you can do it, Jeff. Can you do it? Shut up. I'm serious. Sure. Can anybody tell me where the vertical asymptotes are? What do you have to do first? Why was this one so easy? This has only got one piece. What's this? What do I have to do with this?
Yeah, factor it out.
Yeah.
X minus 5 and x plus 3.
Kick ass. So the vertical asymptotes would be where?
It'd be 5. Well, x equals 5 and
Yeah.
x equals negative 3.
X equals negative 3. You got to write them like that because they are lines, right?
Yeah.
I like it. Kick ass. Okay, so that's pretty simple. The reason you cannot cross through a vertical asymptote is because it's where the domain has problems, and there ain't no getting around that shit. I do want to mention one thing though. This one's a little bit different. You should be able to see right away why this one's a little bit different, but I want to really make sure you understand what's going to happen. You make this a little bit, so this one. So when you do the same thing, right? But then what happens?
You can cross them out. Cross out x minus 2.
Yes. But you got to be careful. Let me ask you right now, what is the domain of H?
Plus or minus 2, right?
Yes. Well, X can't be plus or minus 2. But where are the vertical asymptotes? There's only one at x equal -2. So what happens at x equals 2? Who knows? What happens at x equals 2? In fact, I think I want to show you. I'm going to show you in the calculator. I always kind of hope that somebody out there is plugging some of the shit in the calculator as we go. I sort of don't want you to, but at the same time, I'm like, that's what I'd be doing right now. Jeez. Where are you? There you are. All right, so let me share this. The app that takes forever. There we go. I think that was on the commercial for this thing. All right. You'll wait because it's cool. You guys remember this, our piano? That was us, right? I think. What was the other class? You're cheating on us, but shut up. So if I put this function in, I do have to tell it, this is on the top and this is on the bottom. That's right, right? That's what it's doing. Yeah. So now watch what happens when I graph this. Just so I know my window is freaky as shit right now, based on the stuff we were doing before. Somebody do zoom. What do I hit? Zoom?
0. For
No.
zoom fit, right?
Oh, I see what you're saying. I'm just going to do zoom 6 because I know this is going to be relatively well behaved. If I do zoom 6, it just becomes a 10 by 10, 10 by 10 screen, right? I appreciate the zoom fit though. I'm curious just because you said that. Let me see what it does. Oh, it does exceptionally weird shit. Sometimes zoom fit is just so weird. So why does this make sense? How many asymptotes do you see? You know, see.
2.
Well, I like it. You're right. You're right. But one of them is a horizontal asymptote we haven't talked about. How many vertical asymptotes do you see?
1.
1. Jives with 1, even though there's 2 problem locations for the domain. We cannot see on here the other problem spot and what happens. But real quick, do you see above trace where it says calc? So all this stuff up here is basically graphical stuff. So if I want to calculate something graphically, so if I want to calculate a value, for example, if I put 1 in, it tells me the output for when I put a 1 in. Amazing. Well, look what happens when I try to put a 2 in. Do second trace to get the calc value. And if I put a 2 in, this is so awesome. Watch this. What did it get?
Got an error.
Unknown, right? And that makes complete sense. It actually relates to how you would graph it. Does anyone know what I would put at, in fact, does anyone know? So it looks like 2 goes somewhere, doesn't it? It looks like 2 goes somewhere. Does anyone see how to find out where 2 tries to go? Does 2 work in this? No,
No.
right? 2 does not work in this. Does 2 work in this? Yeah, right? Because the bottom is x plus 2. What do you get when you put a 2 in?
You get 1/4.
Good. So the only input that this isn't valid for is 2. because it is this function. It's just been reduced. So 2 is not the domain. So it's sort of the same idea as me doing the little parentheses, remember? The little parentheses. I'm going to put parentheses around 2, put it in here and go, oh, it wants to be at 1/4. And sure enough, I'm sorry, I'm sharing as I'm doing that, but sorry, everybody, if you couldn't really see what I was doing. But if you look at this too, if I trace and I try to get to 2, see how it's dancing around 1/4? Right?
Yeah.
Okay, thank you. Sweet. Okay, enough of that. Let me see. What was that other thing I wanted to tell you about? It's almost time. Oh yeah. Okay, let's come back to this.
Wait, so does that mean for 2 in that equation that 1/4 is or isn't actually part of the line?
1/4 is not. It would be an open circle there. So if you had to graph this by hand.
So it'd be like an open circle in the middle of the line.
Totally, yeah.
Weird. Okay.
Freakadelic. And it makes sense. So you're not allowed to use 2, but 2 does have an output for this alternate version of the function. So it wants every single point that isn't 2 follows this. So then what must happen right at 2? There must be an empty spot. And we recognize that by putting an open circle. And this is interesting because I like your response, because you've seen graphs with holes in them, right? You've seen graphs with holes in them and whatever, but now you're starting to see how they happen naturally, these holes. Okay. So last thing for today, I want to look at the beginnings of horizontal asymptotes. And we saw one from this guy, so let me start with that possibility. Let me see. Okay, go away. All right. So horizontal asymptotes, that up herefore known as ha. Sure. So the most basic, there's going to be 3 of these. Let me actually number them. Wouldn't that be neat? 1, 2, 3. So the first way to have a horizontal asymptote is to, like, the most basic function would be something like 1/x. And the idea of a horizontal asymptote, the vertical asymptote, it would be what? What would the vertical asymptote be for this?
0.
0. X equals 0. So it'd be x equals 0, it'd be the y-axis, right? The horizontal asymptote is what happens to f of x as x goes to plus and minus infinity, as x gets really, really big, positive and negative. So horizontal asymptote is connected to n behavior. So it's n behavior when I'm talking about rational functions. Is that all right to say? Because you guys know n behavior is all about letting x get really, really big. So what happens as I let x go to infinity and negative infinity? What happens?
It's really small.
Yes. So as x goes towards infinity, f of x goes towards
0.
0. I like it. It never gets to 0 because the only way to make a fraction 0 is to make the top 0, and I cannot make the top 0 because it's freaking 1. So then this would have a vertical asymptote here, right, and a horizontal asymptote here. And then I could plot a few points. If I plug a 1 in, I get 1. So it looks like this. Yeehaw! And if I plug a -1 in, I get -1. That's crazy. So it looks like this. Yeehaw! Now let me this is part A. So this is still the first type. I think we'll only do the first type tonight, and we'll talk about the other 2 types tomorrow. So another way to look at the first type. So really, the important thing that happened here is which side has a larger degree, the top or the bottom?
The bottom.
The bottom. So if I create a function that is something like x minus 1 over x squared, well, let's do the one we just did. Should I? Sure. X minus 2 over x squared minus 4. Right, we just did that. So the vertical asymptote we know was at x equal, where were you? -2. We just did this one a minute ago, right? The horizontal asymptote, I've got to do a little bit of work. So notice something. Do you see how I know that as x goes to infinity, 1 over x goes to 0? So I want to show you the standard process, and then we'll talk about some shortcuts, but you got to do the standard process a few times. So here's what I do. If I divide the top and the bottom by the largest degree variable. So what is the largest degree variable? In here, what's the largest degree variable?
The x squared.
X squared. So if I divide everything by x squared, what do I get? I'll get x over x squared, which is 1 over x, minus 2 over x squared, over x squared divided by x squared is 1, minus 4 over x squared. Now, what does each of these things do as x gets really big? What does this do as x gets really big?
Approaches 0.
What does this do?
Um,
It goes to 0 even faster. What about this one?
yeah, same thing, I guess.
Same thing. And of course, 1 doesn't give a shit what x does. So what do I get? I get 0 over 1, so this goes to 0. Anytime the top degree is less than the bottom degree, your horizontal asymptote will be y equals 0. So that's when the top degree is smaller than the bottom. So it kind of makes sense. As x grows, the bottom grows faster. So x is getting bigger, but x squared is getting bigger faster. So I'm dividing by relatively more and more, which means my output is getting less and less. From what I just said, you can understand what the other two situations are going to be. When the degrees are the same, and when the top degree is bigger than the bottom. So those will be the two other situations that we talk about tomorrow, because I think I have thrown enough at you, and I had to almost kill myself just to make it a complete class.
Wait, so you said that if the top degree is less than the bottom degree, it does what again?
Does this.
Just
So
approaches
it's,
0? Or?
It's a higher degree than the top. That means the bottom is growing faster. So if I keep dividing by bigger, 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 obviously I'm going to get smaller, smaller, smaller. So that actually makes a ton of sense. And this is just the technical way to show that. But the shortcut is just, so if I had x cubed with lower, and I had x to the 8th with lower shit, that's going to have y equals 0 is a horizontal asymptote. Done. Next. It's the other two situations that get a little worse, especially the third situation. Gets really neat, which when I say that probably makes you scared. I understand. That's where we're going to get stuff called slant or oblique asymptotes. Excuse me. Okay, so that's enough. I'll officially call it a class. If you have any questions, stick around, let me know. Otherwise, you are free to exit. Go play some Outer Worlds or something. Yeah, there you go. Exactly. I had played through it once already. Then the new DLC came out, and I'm like, oh, let me start from the beginning. All right, everybody here good? I don't see anybody with a question, so I'm gonna leave.
I don't know. My only question would be like, just the stuff we went over today. What section of the book are we going over right now in class?
5, 6, if I remember correctly. 5, 6 is rational.
5, 6.
5, 6.
Okay, got it. Is 5, 6 assigned yet?
Oh, I haven't created a place to turn in, so I'll do that right now.
Okay. Got it. Okay, that's it for me. Thanks for class, and yeah, sorry for asking so many questions.
No. Don't ever be sorry for that. If you're asking too many, I'll say something, but
Got it.
it's hard to ask me too many questions.
All right, well, thank you.
No problem. Oh, good. So I need to find out. Let me see, Sylvia.
My mic was muted the whole time.
Oh, were you trying to talk to me?
I was talking. I actually have a question about my quiz. I got a 0 because it says that I didn't access it, but I accessed it.
But what's weird to me, and you have to help me understand this, is you accessed it after you did it, which I don't understand. So you turned it in at 2:01.
Yes, I actually turned it in before that, but my computer was taking really long to upload. I have a video of me submitting it before too.
I don't care about that because that's fine. I don't care about that. What I care about is there were 4 different versions of the quiz.
Okay.
So, but I don't know how you knew which problems to do because you did the problems before you looked at them.
Well,
so that made me worried.
No, I clicked on launch the quiz and it showed me those, I think there are 5 or 6 problems. I mean,
But you did that after, so let me double check.
because I started the quiz, I started it like at 1:20, so.
Okay, so you ended at 2:44, or at least that's when you closed the quiz. All right, so you started 80 minutes before that. So you did start about 1:20. Okay, that answers that. So I'll grade it. I was looking at it with less detail.
Yeah.
So I tried to, and now I opened up this more detailed place, and
Yeah, because
all I
I
saw was
was
you.
scared. I was like, what the heck?
All right, so I will grade it right now.
Okay.
And please, my apologies. I
It's
just
okay,
have,
no worries. But I thought I would ask because it said 0 and I was like,
well,
oh.
of course you should ask.
Oh,
I was
like,
hoping you would be here and ask because I was curious if I was looking at it wrong, and apparently I was. And so that's my fault, and I apologize.
it's okay, don't worry.
It's just that all the teachers are a little bit, extra careful now with cheating and stuff.
Yeah, I was like,
try not to be so bad because then I tend to hurt my students who aren't cheating. So you're fun. I'll go ahead and grade it right now so you can correct it if you want to. Let me see.
okay, cool.
Okay.
Thank you. I'll see
problem.
I'll see you tomorrow, hopefully.
Okay. I'll see you then.
Before the recording ended, you said my name. So was that because I stayed or because you had a question as to my test and all that stuff?
Oh, I'm still recording, but